Hey folks, I'm Mr. Hartzler, and I want to talk to you about finding the zeros of polynomial functions. We're going to go through a ton of examples, so if the first one's not one you're interested in, just skip on to a later one, and hopefully it is helpful. And please like and subscribe the video in this channel, and hopefully you can see more of these great videos. If you have suggestions, leave those down in the comments below, and let's get started. So here's our target, so you can model and solve problems using the zeros of a polynomial function. Here's our first example. So we're going to use zeros to graph a polynomial function. The first thing I'm going to have to do here is set up a little bit of a number line. I think that's usually the best way to start here. I'm going to give myself, let's see, a 0 here. So now we have a little graph on there. And I'm going to go through and find each of my zeros. We know how to do that. We've done that in the past section. So I set each of these 3 chunks equal to 0. So my first one is just that initial one hanging out in the front, x equals 0. And there's nothing to solve for there, it just is x equals 0. The next one is the x minus 3, set it equal to 0, and I'm going to solve for 0. So I'm going to add, or sorry, solve for my x. I'm going to add my 3 over, and I get x equals 3. So I know I cross at those 2 points. So I'm actually going to put those 2 on the little board while I got it. So there's a 0, and then 1, 2, 3. Put a 0 there. My next one, x plus 2 equals 0. I'm going to subtract 2 over, and x equals negative 2. So I have another one right there. Now I need to figure out, what does this graph do, right? Does my right side go up? Does my right side go down? What's happening here? So I'm going to take a little table, and I'm going to plug some stuff in. So let's see, the x chunk, the x minus 3 chunk, and the x plus 2 chunk. All right. Now let's take a number all the way to the left of all of these numbers. So that's at 2. Let's do 3. I'm going to plug a negative 3 in. So this chunk's going to be negative. Negative 3 minus 3 is going to be a negative. Negative 3 plus 2 is a negative. So then the product of all of that, negative times a negative times a negative, gets me a negative. So again, all I did there was I pick a number somewhere in each of these intervals. To the left of my farthest left dot, I'll pick one between them. And then I'll pick one between these two. And then I'll pick one to the right of all of them. And I'm going to substitute it into each chunk, multiply them all together, because that's what my function is, and see if the total part of that is negative or if it's positive. So now I'm going to pick a number. Oh, so actually that means I'm negative, so that means I'm down here somewhere. Now I'm going to pick one between these two. There's really just one good option, negative 1. So that's a negative. Negative 1 minus 3 is a negative. And then negative 1 plus 2 is a positive. Negative times a positive gets me positive. That means I must go above, right? I must be positive, so I'm above my x-axis. And I know I intersect the x-axis at these 2 points, so it must look something like that. Then I'm going to go through and find one between these two. 1 is an easy one to plug in. So that's positive, that's negative, and that's positive. So I end up with negative again. So that must mean I go below. And then, of course, I have to pick a number that is farther to the right, which let's do a 20. So it's going to be positive, positive, and positive. That chunk is positive, so this side must go up. So it looks roughly like that. So that's how I used my zeros to pretty much find out what the graph is. Then I plug in some numbers to the to the left of everything, between each dot, and then to the right of everything. And that'll pretty much get you a rough guess of what it looks like. All right, folks, let's go on to our next example. All right, so this isn't an example per se, but it is talking about multiplicity, which is very important for us. So if our multiplicity is even, right, 2, 4, 6, 37,002, something like that, then we'll have, right, an even exponent, and that means I'm going to bounce off those coordinate points, or those x-intercepts. So in this case, I have a negative 2 over here, and I've got a positive 6. 1, 2, 3, 4, 5, 6. Those 2 points. I know I'm going to bounce off of them. I know my leading coefficient is going to be positive, because it's a positive 1 out in front, and then all of these leading coefficients inside the parentheses are positive, so it's all going to be positive. So I know my ends go up, and that must mean I bounce off of these points and I come back something like that. I'm never going to pass through them because these numbers are even. Okay, it's again very rough sketch, but you get the rough idea there. And down here, these are both odd multiplicities. So I've got a 1, and then over here a negative 13. Again, it's going to be an odd degree. Or actually, sorry, total, it's an even degree, right? 7 on this x and a 1 on this x. So that actually means both sides are going in the same direction, and both sides are actually going to be going up because my leading coefficient is also positive. But I go through both of these points, so it's going to look something more like this. If I have an odd multiplicity, I'm going to go through that x-intercept. Okay, that's an important piece to get from this. And again, even multiplicity, I'm going to bounce off of that point. And that all comes from the exponent on my x, or on that factor, right, that has an x in it. So let's go on and do an example. All right, so we're here. We need to find the real and complex zeros. So first off, how many real ones am I going to have? Well, just the one. I only cross my x-axis one time. So here is my real 0, okay? And then I'm actually going to use this to find all the other ones. But my complex ones, how many do I have total? Well, it's going to come from my degree. If I have a degree 3, then there's 3 zeros. They just might not all be real. And in this case, there's only one real one because I only crossed my x-axis once. So there's 2 complex ones. So I have this first step. Use what the graph gave me. I know I cross at 3, 0, or where x equals 3. So I'm going to use synthetic division here. My main polynomial is already in descending order. X cubed, x squared, x, no x's. So I'm going to take those coefficients. I'm going to bring them down here. 2, -8, 9, and -9. What number goes in my little box here with synthetic division, right? I'm going to use, that's what I said earlier, I'm using synthetic division here. Well, I'm going to take this 3 and put it in that box. So this first chunk comes down. I get a 2. 3 times this 2 gets me 6. I always add straight down, so I get a -2. 3 times my -2 gets me a -6. Add straight down, I get 3. 3 times 3 gets me 9. Add straight down, I get 0. Okay. Now I need to bring back in all my x's. So I start off with a degree 3, divided by degree 1, so I end up with a degree 2. So this is now x squared, x, and no x's. And that's my remainder right there. My remainder being 0 means this is a factor. So I'm going to rewrite this whole thing so I can really see what it looks like. All right, so we're here. Right? We know that this is a good, nice, clean, pretty factor. Our remainder was 0. Good. So this whole thing factors to x minus 3 times 2x squared minus 2x plus 3. But I know how to factor that further. This chunk here, right, that piece, that gets me my first main part. That was where I'm crossing my x-axis. This other chunk is going to give me my 2 complex roots, 2 complex zeros. And I know that because it's an x squared, and I'm predicting 2 complex zeros. To find those other 2, again, they're complex, so I'm not going to be able to factor this nice and easy. Instead, I'm going to use quadratic formula, and that should help me find my other 2 relatively simply. Okay? I'm going to set up the quadratic formula, and then we're going to plug everything into it. All right, so I have all of that all plugged in. Now I need to simplify it a little bit further. Okay, we're getting pretty close. I'm running out of space. Let's see what I can do here. All right, this can simplify a little bit further. All right, so I broke that up, right? Square root of 20. Square root of a -20, actually, splits up, and it becomes square root of -4 and a square root of 5. Square root of -4, we talked about this in a previous section, that's 2i, and a square root of 5 just has to stay that way. Now I can actually cancel out those 2's with that 4, so x equals 1 plus or minus I times the square root of 5 over 2. I canceled out both those 2's in the numerator with one of the 2's in my denominator. That's why that 4 is now reduced to a 2. So this here are my 2 complex roots. I have a real 0, a real at x equals 3, and I have complex, and I'm writing this up in the top left. Complex is x equals 1 plus or minus I times the square root of 5 over 2. Those are all of my roots. So again, I used my graph in order to do synthetic division. which gave me this polynomial right here. We actually call that the depressed polynomial. Depressed because it's lowered, it's brought down because of that factor out in front. So really the main goal in all of this is to factor as far down as I possibly can. I use the graph to do it, and then I go through and I use quadratic formula if I can, or one of my other factoring techniques. Let's go into another example, and I think that's going to be helpful. So now we're here. We need to factor this one. Now, I don't give you a graph, and I don't give you a calculator for most of any of this either. So I actually just have to factor it. And this only has 3 terms, which we factored 3 terms things in the past, right? If I told you this was x squared minus 10x plus 16, you could factor this, right? What things multiply to give me the 16, add to get me a negative 10? Well, let's see. A 4 and a 4 get me a 16. A 2 and an 8. Ooh, 2 and an 8. I have to add up to get a negative 10, though, so it has to be negatives for both of these. So that would be an x minus 2 and an x minus 8, right? We'll double check here. X times x gives me the x squared. X times negative 8 is negative 8x, and then negative 2x, and then positive 16. Okay, cool. That's just me going through in my head, foiling, right? The first, outer, inner, and last to try and make sure I get to this original. But this one is slightly different. But not much, right? I mean, this x to the 4th minus 10x squared plus 16. So what if it was just x squared and x squared? And then still a negative 8 and a negative 2. Does that still work? Let's check. So yeah, that does it. So this chunk is how it factors, but now I have to set each of those equal to 0, and I need to solve for my zeros, right? My x-intercepts are where my y value is 0, so that means f of x is 0. So set that equal to 0, and then set each subsequent piece equal to 0. I'm going to clean this up a little bit, and then we'll take another look. All right, so cleaned up a little bit. We're here. I need to set each of these pieces, this one and this one, equal to that 0. So 0 equals x squared minus 2, and 0 equals x squared minus 8. And I'm going to add the 2 over, add the 2 over. So 2 equals x squared. I'll square root both sides. And x equals plus or minus the square root of 2. Well, 2 is a prime number, my only even prime number, so I can't simplify that anymore. And then here I'm going to add the 8. Add the 8. 8 equals x squared, square root both sides, and x equals plus or minus 2 square root of 2. Now, you remember how to do that? So I'm going to do it way over here on the left. So square root of 8 breaks up into a square root of 4 times the square root of 2. Square root of 4 gets me a normal 2, and then the square root of 2 can't simplify. We just talked about that. So I get these two things together. Boom, there it is. All right, so all 4 of these are my, well, are they real or are they complex? They're real, right? I'm allowed to take the square root of a negative number, or sorry, of a positive number. So they are, in fact, real. I have 4 real zeros, and they're at x equals plus or minus square root of 2, comma, plus or minus square root of 8. But I remember we decided to write that as plus or minus 2 square root of 2. Let's go on to our next one. So now we're here. Has 3 terms again, but I don't think I can factor the way I did the last one. You'll notice, though, they all have x's. So that means GCF. I'm going to factor the GCF out of all of these. So I have x, and then I'm left with x squared minus 8x plus 16. I need to continue to factor, or if you don't like factoring, use quadratic formula. That's fine too. But I hope they factor. Oh, it does factor to an x minus 4 and an x minus 4. Negative 4 times negative 4 gives me a positive 16. Negative 4 minus 4 gives me that negative 8. So it works. Now I need to find all my zeros, right? Real and complex. So I need to set each of these chunks equal to 0. Because remember again, my zeros are also another word for my x-intercepts. To find an x-intercept, you set y equal to 0. So 0 equals x, x minus 4 equals 0, and x minus 4 equals 0. So that one's just done, right? X equals 0. I'll switch it around because I like that format better. And then x equals 4, and x equals 4. So really, my x-intercepts are 0 and 4, but 4 has multiplicity of 2. That happens twice. And I actually notice it here, right? We have x and then x minus 4, and I would write that squared. So it's a degree 3. Should have 3 zeros, and I do. The 4 just happens to happen twice, right? 2 times there. All right, so let's go look at another example. Find all the real and complex zeros. Ooh, whole bunch of stuff, right? There are 4 terms this time, but we know how to factor things with 4 terms. We factor by grouping. So I'm going to group the first 2, my last 2. Though it doesn't have to necessarily do that. All right, so my first 2, my x cubed minus x squared, and then my negative 25x plus 25. All right, I'm going to factor my GCF out of each chunk here. So this is an x squared, and I'm left with x minus 1 plus, and then what's my GCF here? Okay, probably 25, and then a negative x plus 1. My hope was that both those sets of parentheses would look the same. So instead of a plus 25, I actually need to factor out a negative 25. So factoring out a negative from here makes that a positive x and a minus 1. Perfect. Now my parentheses are the same, and I can pull those out front. So pulling those out front, there's my x minus 1. And then my x is going to come over, my 25 is going to come over. I have an x minus 25 right there. Ah, I see what I did here. I made a little mistake, right? Back up here, I didn't factor just out an x. I factored out an x squared. So that's a squared, so that's a squared. Whew. I was worried there for a second because x times an x was not going to get me x cubed. But an x times an x squared will. So actually this one, this chunk right here, it factors further, doesn't it? That looks a lot like one of the 4 formulas I told my students to memorize. Remember which one it is? Can you notice? Can you tell? Can you? It's difference of squares. Difference of squares. So x squared minus 25, that splits up into an x and a minus 5 and a plus 5. So let's do that. I have x minus 1 and an x plus 5, x minus 5. Again, that last part there was difference of squares. And you'll notice that that kind of pops in and pops out. Same thing with difference in sum of cubes. That will just happen every so often as you're factoring. Those are one of the factoring techniques we have. And now I actually need to find the zeros. Right? I've broken this down, but I haven't actually found anything. So I'm going to do that right here. I have an x minus 1 equals 0. That gets me x equals positive 1. And then an x plus 5 equals 0. And that gets me x equals negative 5. And then I have an x minus 5 equals 0. And that gets me x equals 5. Did I find all of them that I expected to? So first, how many should I have had? Well, my degree is 3. So I would expect 3 zeros. Cool. Did I find 3? 1, 2, 3. So I must have found them all. And they're all, in fact, real, which is kind of neat. I like the real ones. So let's go on and try our next example. All right, so now in this one, I need to solve this polynomial equation. Well, the first thing I should probably do is combine any like terms that I might see. So I need to get maybe everything over to the right. Let's start off with my x cubes, I guess. I'm going to subtract this x cubed, and I'm going to subtract this x cubed. Well, look at that. They cancel, don't they? X cubed minus x cubed gets me 0. X cubed minus x cubed gets me 0. So now I'm going to do all of the other stuff. I'm going to get everything over to the right because that's where most of my junk is anyway, right? So I'm going to add 7x, add 7x. I'm going to subtract this 6, subtract this 6. Now I'm going to use that little blue line that's already there and see what we get. Negative 7x plus 7x, 0. 6 minus 6, 0. Awesome. Whole left side, 0. Then I have that 5x squared. Nothing was done to it. And then negative 2x plus 7x. That gets me a positive 5x. Then I have negative 24 minus 6. That's negative 30. Then you know what I happen to see? You guessed it. My GCF, my greatest common factor. That shows up all the time. It can be a great way to make a as a teacher, for me to make one of the equations slightly more complicated, right? Just throw in a 5 to everything. So be mindful of that, and in this case, factor it out. So we're going to pull a 5 out. I'm left with x squared plus x minus 6. I have to continue to factor this so that I can try and solve it. So that means What two things multiply to get me this -6 and add up to get me 1? Well, that's going to be x and an x here for get me my x squared, and then a +3 and a -2. 3 and -2 multiply to get me a -6. They add up to get me a +1. Now, since I am solving, I'm going to set each of these pieces equal to 0. So 5 equals 0, x plus 3 equals 0, and x minus 2 equals 0. Then I have to solve each piece. Well, first off, does 5 equal 0 ever? No. So that doesn't provide me with any 0. It just doesn't. Then I subtract this 3 over. X equals -3. Then I add this 2 over, and I get x equals 2. So I have two real roots, in fact, a -3 and a 2. Not too bad, right? Let's go on and look at our next example. All right, so now we're here, and we're going to try and find all of the solutions of this inequality. So there's not an equal sign. It's actually a less than sign, so we're an inequality. And I want to factor it first, find all my x-intercepts, and then we're going to go from there. So in this case, I actually have a GCF again. You'll notice I do a lot with my GCF. It is super helpful, makes all my numbers a little bit smaller, everything more manageable, and it also typically finds one of my zeros. So the greatest common factor here is actually 2x. So a number and a letter here. So I have 2x, and the piece that's left is x squared plus 6x plus 6. And that all has to be less than, just less than, not equal to, just less than 0. I need to keep factoring or breaking this down at least, but by golly, I don't think I know anything that multiplies to give me a 6 and adds to get me a 6, right? It's just 1 and 6 and then 2 and 3. None of that combination is going to get me anywhere near that. So I'm going to have to use the quadratic formula on this little chunk. We're going to ignore the inequality for right now. Okay, I just know all of this needs to be less than 0, but I need to first find my zeros. Let's write down the quadratic formula and then plug stuff in. All right, so now it's all plugged in. I need to simplify. So I have a -6 plus or minus 36 minus 24 over 2. That keeps simplifying, right? -6 plus or minus square root of 12 over 2. But simplifying square root of 12, I'm going to go up to the top right of my screen. Square root of 12 breaks up to a square root of 4 times the square root of 3. Square root of 4 is just a normal 2. And the square root of 3 cannot be simplified because 3 is prime. So I am left with that. So this actually gets me a -6 plus or minus 2 times the square root of 3 over 2. And I'm going to cancel a 2 in everything in my numerator and in my denominator, which gets me a -3 plus or minus square root of 3. That are my 2 zeros from that chunk, which I would have expected. It is a degree 2. All right, so now I'm going to do a quick little number line. So I have one here, and one here. So I have my first one, this 0, 2x. Well, that's just going to get me 0, right? A 0 plugged in gets that all equal to 0, so 0. And then I have -3 minus the square root of 3. Don't know what that is, but it's over here. And a -3 plus square root of 3. Ooh, actually, that's probably here. -3 minus square root of 3. So I have a point here, here, and here. Now I need to figure out, what does the rest of this graph look like? It's a positive leading coefficient. It's an odd degree. So that means my right side goes up, my left side goes down. Each of these x-intercepts, right, the one from this term here and then these two, they each only happen one time, which means I pass through those, right? A multiplicity of an odd number means I go through that coordinate point. Okay, so now where is my graph, right? Because that's what this whole thing is here, is my graph. When is that less than 0? Well, that's everywhere below my x-axis, which means my solution, or actually solutions, is from -infinity up to -3 minus the square root of 3, whatever that number is. And it's also from -3, oh, sorry, plus, that should be a plus there. So it's still 3 minus, or -3 minus the square root of 3, and this one is -3 plus square root of 3 to 0. Those are my two solutions, right? There's all of those numbers. And those, again, are intervals. So all of those are x values. Okay, my whole question had x's in it, so I need to have some x's in my answer here. So what solutions, what are my x values that this could be? And it is from negative infinity to negative 3 minus square root of 3 and negative 3 plus square root of 3 to 0. It is on those two intervals that my solution is, because that's where I am down here, which is below my x-axis, which I hope we can all agree is less than 0. All right, so that is our last example. I hope this was helpful, and I wish all of you a phenomenal rest of your day. As always, like that button if it was helpful for you, and subscribe to the channel if you want to see more like this. If you have some comments, or if I made an issue like I did in my last video, then leave that in a comment down below, and hopefully I can get through and fix it. And if nothing else, I'll leave the correction in the comments and down as my description, so you can hopefully see it there and understand that it's me, not you, that made the problem, made the mistake. Have a phenomenal day, everybody. Do math carefully and with enthusiasm. Bye.